Hey guys, welcome to the channel vibgyoroftalents. So it's been a while since I've not uploaded any video, but now I'm back with another extravagant video. So in today's video, we'll be looking at the chapter Light. So it's a chapter 10 of class 10 NCERT. It's basically a physics chapter, so many people might be feeling a little difficult in physics during the 10th and plus 2 classes. So I'm gonna make it very easy. So please follow with me to get good marks and get rid of the fear of physics. Alright, so with no further ado, let's get into the chapter right now. So first of all, let's get some basics about light. So we might have learned it in the previous classes, or you might have already known about them from the basic environment that you are around in. So let's just revise them and brush upon them. So first of all, any teacher who would have taught you about light during the previous classes, like maybe in the 5th class or 6th class, would start with this basic sentence that light is a form of energy. So at that instance, you might be thinking that, oh yeah, so from tomorrow, I'll stop eating food and I'll start eating light. It has energy in it. So if I consume that light, so even I'll get energy and I'll get super muscles, then I can flex my body. No, that's a wrong approach. So eat your food and not light. Alright. So the second thing that we are going to remember, or we already know, is that light is an electromagnetic radiation. So we know about electric radiation. So we might be using laptops or mobiles, and even now the mobile or laptop or the PC which you are watching this video in is generating some type of radiation. So that comes as the electric radiation. And now what is magnetic radiation? So magnetic radiation is the radiation that is being generated by a magnet. Alright, so if we create an electromagnet, the radiation generated by that electromagnet is simply known as an electromagnetic radiation. The best thing about electromagnetic radiation is that it doesn't need any medium to travel. For example, for sound to travel around us, there should be some medium. So what is the medium around us? It's air. But for light, you don't need any such medium, as it is an electromagnetic radiation. Light can even also move in vacuum. Right. Let's move on to the next point. So Newton stated that light is made up of corpuscles. So basically, corpuscles is the fancy name for the word particles itself. So as you are growing classes, there is nothing new that is being taught by the school and the teachers. They're just giving fancy names to the older things that you might be knowing. So yeah, keep that in mind and just study. I would have just told that light is made up of corpuscles. But why did I say Newton stated that light is made up of? You might be wondering about that. But just wait, you'll know the reason very soon. So for now, let's move on to the next point. Before that, have a look at this image. So you'll know how the particles move from air. So first of all, the light is coming from air and it hits the mirror down below, and those particles are being reflected back. So we have been knowing about this phenomena in our daily life too. Alright. So reflection is the bouncing back of light when it hits a smooth object or a polished surface itself. So you might be knowing about reflection, you might be seeing in everyday life. Even now, there is some light source around you. So that hits some object and it's hitting your eyes, or maybe the light is directly being passed into your eye. So that is also just a reflection. Now you are actually observing reflection and having reflection around you. So actually relate things to your everyday life and the environment around you, so that it will be very easy for you to actually visualize it and also remember it. Cool. So then, refraction. You might be knowing about refraction too from the previous knowledge. So refraction is the change in the path of light in going from one medium to other. So in the previous year's textbook 2, you have been seeing one image that if you put a pen inside water in a small mug, and if you observe it, the part which is not immersed in the water would be slightly different from the part which is immersed in the water. They won't be in the same direction. I cannot use the word direction. I can say the pen won't be visible as straight. You can see a break in between when there is change of medium. That is when the water starts. So you can see a light scratch-like thingy between them. So that is known as refraction. So if you don't remember it, I will leave the link in the description so that you're going to go there and explore more about it. So yeah, we are done with all the basic properties, what we have learned in the previous classes. So now let us actually jump on a little bit further, and I'm going to teach you some properties of light. So these are actually not mentioned in our textbook of NCERT, but yeah, if you understand these things pretty well, the 11th standard will be more easier if you understand these things now, and it can also make the further concepts more clear. So yeah, let's get started. So there are three basic properties of light that we are going to discuss now. As we have discussed two properties before, it is reflection and refraction. These are going to be little different from those. Alright. First of all, we have something known as diffraction. So how can we define it? So diffraction is a slight bending of light as it passes around the edge of an object. As I've said you right before, you might actually experience it around the environment that you are in. You might have already seen diffraction taking place many times, but you actually don't know this certain term of diffraction, so you are not able to remember it. But now I'm going to show you a picture. So this might get your all doubts clear. So as you can see in the first part, that there is a wide gap between those two blocks. So the light is passing there, and when there is a wide gap, there is small diffraction effect. Whereas in the second condition that you can see there, as there is less space, there is narrow gap between those two blocks, the light rays are touching the edges of that object, of those blocks, and then it's getting a little bit diffracted. It is getting curved. So there is a large diffraction effect when there is less space between two objects, right? So there is a smooth curve around when the light rays touches the edge of that object. So that was the diffraction property. It was really simple for you, I guess. So now let's move on to the second property, so which is constructive interference. So constructive interference occurs when the maxima of two waves add together so that the amplitude of the resulting wave is equal to the sum of the individual amplitudes. Oh, this seems complex. So I'm going to simplify it for you. Alright, so have a look at this image that you have here. If we have to say it in simple words, so when two rays are moving in the same place and they are overlapping each other, then the displacement of the wave increases. That is simply called as constructive interference. So as you can see in the picture also, so one wave is going above and there is another wave which is below. So if they are in the same direction and in the same place, they are going to get added up and the displacement of it increases. So this phenomena or property is known as constructive interference. Alright, let's move ahead to the third property. So that is destructive interference. So it's kind of opposite to constructive interference. So destructive interference occurs when a positive displacement of one wave is cancelled exactly by a negative displacement of the other wave. The amplitude of the resulting wave would be zero. So that is destructive interference. So if I have to say it in a simpler way, we can say that when two rays are exactly opposite, then they both nullify. So that is known as destructive interference, just single line. So this would be more easy for you to remember. What happens is that when two things are exactly opposite, what happens is that they nullify. They get cancelled. We know it from before. So the same thing is being applied in the property of light too. So when two rays are exactly opposite, two light rays are exactly opposite, then they both nullify. So this property is just simply known as destructive interference, and in this picture too you can actually see how the light rays are being differentiated. From this image also you can understand that how differential both constructive interference and destructive interference are. They're both kind of opposite. Alright, so just remember it in that way so that you'll remember both of them by just remembering one property, that when two similar rays they are moving in the same direction, they add up, and when they are exactly opposite to each other, then they nullify. That's it. I just gave you a small introduction of these properties, but if you want to know more, I will definitely leave a link in the description so you can go there, and if you are interested you can check out more about these. It's going to be really interesting, I promise you that. So yeah, now you might be asking me that why have I taught you all these new properties that are not there in the portion itself. So the answer to that question that you have is going to be here right now. So as you can see that in the before properties that we have studied, that is maybe the reflection or refraction, there we were treating light as a particle. So Newton thought light as a particle. I've studied in the before also that Newton thought that light is a particle, and then he made his own assumptions and he made his own theories and written it. But then the later scientists said, no, it's not a particle. I don't agree with you. So it's a wave. So they just didn't randomly say it because to oppose to him, but actually they have also proved their own idea. So some properties of light have been proved taking light as a wave. For example, we have just seen about diffraction, constructive interference and destructive interference. There are many such things that are being proved as considering light as a wave. But we have also known some of the basic properties of light that have been proved taking light as a particle. For example, we have known of reflection and refraction. There are many other properties which are also made proved by taking light as a particle. So we cannot say which is wrong and which is right. So as the light is being proved in both the conventions, that as a wave as well as a particle, light is very special. So we should treat it in a different way. So yeah, let's solve this case now. The case has come to climax. Now the case is solved. So light has a dual nature. It can act as both particle and wave. You can also think about it in your own way. So as we have seen before, as some scientists have done taking light as a wave, they have made their own proofs and they have made their own assumptions and activities and experiments. Some other scientists also took light as a particle, like Newton. So he took the light as particles. He thought it was made up of particles and he made many theories and also he made many experiments. So we cannot ignore any of them as both are true. So we say that light has a dual nature. It can act as both particle and a wave. So if you didn't understand this till now, so I'll give you a quick example. So this is how you look the day before PTM. You act very sincere and you try to act your best in front of your teacher because the next day teacher is going to reveal everything about you. Mostly the teachers would have bad impression about you. So in order to cover that, you will act very good on the before day so that there won't be much negative impression on you. Whereas on the last day of school, you would enjoy as much as you can because there is no limit and there is no chance for the teacher or anyone to actually tell to your parents. So this is just an example. So you are the same in both situations, but the situation matters. In one situation, you act very sincere in front of the teacher, whereas in the other situation, you just chill around. You are the same, but the situation that changes your mood, right? So you can think light as also similar to that. In some situation, it acts as wave. In some other situations, it acts as a particle. Okay, cool. Let's move ahead now. As we were knowing that light is made up of particles from the previous classes, no one said us that it is made up of waves. And in the previous class also, we were just being said that light has some properties like reflection and refraction, so which were actually based on light as a particle only. So now as we have been introduced of waves, so let us dive into waves and know about waves more deeply. Alright, so basically waves are of two types, which is longitudinal and transverse. So you might have heard these names when you're studying the chapter of sound in your class 9 too. And by the way, these are not the waves I was talking about. Oh, sorry. So I was talking about these waves, which are light waves indeed. So yeah, let's go and check out what are longitudinal and transverse waves. So what is a longitudinal wave? Longitudinal wave is a wave in which the vibration of the medium is parallel to the direction of the wave travels, and displacement of the medium is in the same direction of the wave propagation. It might be the opposite direction too. So you can see the picture which is being showed here, so to get a better understanding of longitudinal wave. So without actually reading this entire context too, just look at the picture, and when I show you the next picture of the transverse wave, then you'll automatically know what is the difference and you can define it on your own. So yeah, let's move. So this is a transverse wave. So a transverse wave is a wave whose oscillations are perpendicular to the direction of the wave's advance. So this is in contrast to a longitudinal wave, which travels in the direction of its oscillations. So as I have said you that you can make out the differences on your own before I have showed you a longitudinal wave. Now look at this transverse wave. So you might be understanding the basic difference between them. To get a better understanding and better difference between them, have showed each wave together. So the first one is a transverse wave, the second is a longitudinal wave. So in transverse wave you can see that there is up and down motion of that slinky, but in the second one, in the longitudinal wave, there is only parallel movement. Like there is no up and down movement, there is only straight movement. So by remembering this also, you can easily remember both transverse wave and longitudinal wave together. So they are actually both kind of contrast, they both are opposite to each other. So remember the basic difference between transverse wave and longitudinal wave. So now as we were talking about light, you might ask me whether light is a transverse wave or longitudinal wave. So light is a transverse wave. It travels in how the slinky travels in the first picture that you can see. It's for the keen ones among you. Alright, so let's jump back to the basic properties that we have been learning from before. Reflection. So how can we define reflection? When a ray of light approaches a smooth polished surface and that light ray bounces back, this is known as reflection of light. But this is just the simple definition. No, we don't want to make things simple. I want it to be complex. So let's just name everything and search for angles, search for shapes in everything that are around us. So yeah, as we have it in our textbook, I'm going to teach you that too. So have a look at this picture. It's going to actually explain you everything that I'm going to say now. So the incident light ray which lands upon is said to be the reflected of the surface. So the ray that bounces back is known as the reflected ray. So the first ray comes from the sky, or if you take it as sun as the source of light, so it comes from the sky and it falls on the mirror. So that ray from the sun is known as the incident ray, and as it touches the mirror, we make a point there, and as it touches the mirror, it bounces back because we are taking reflection. And I have said you before too, so considering light as wave or particle, what do we consider light as when we are thinking about reflection, wave or a particle? Yeah, it's a particle. Alright. And then the reflected ray is nothing but when the light ray that touches the plane mirror bounces off and goes away from the mirror. So the point where it touches the mirror, so there we draw a perpendicular that goes up. So then the angle that is being formed between the incident ray and that perpendicular, which is known as normal, is known as the angle of incidence. And you might be seeing the other angle that you see there, which is angle of reflection, which is the angle that is being formed between the normal and the reflected ray. Cool. That is it all about the plane mirrors and reflection. Now let us look at types of reflection. So basically there are two types of reflection, which is regular reflection and irregular reflection. So first of all, let's look at regular reflection. So regular reflection is also known as specular reflection in some cases. The regular reflection is the reflection of light rays when they meet or fall on a smooth, also known as a uniform, and glistening surface, which is a smooth surface basically, and where the incident light rays are reflected in only one direction, as you can see in this picture. And when a beam of parallel light rays is incident on a smooth and plane surface, and the reflected rays will also be parallel. That is compulsory in a regular reflection. You can see in this picture that all the rays are parallel, and it is known as the regular reflection. You might be knowing about these reflection types of reflection in the previous classes, but it's just a revision and brush up. Right, so that was about regular reflection, and you can see an example of here. So you can see the regular or specular reflection of the palace and the trees very clearly on the water very near to it. Let's move ahead and look at irregular reflection. Irregular reflection is the reflection of light rays when they meet or fall on a rough, which is a non-uniform reflecting surface, and where the incident light rays are reflected in different directions. So in the previous case, they were all in the same direction, but in the case of incident in the irregular reflection, they're just moving in random directions, not just specified directions. And one more thing that you can observe is that they are not parallel to each other. So this is basically known as irregular, or other name of it is diffuse reflection. So you can see the diffuse reflection of the same palace and the trees when the water is kind of shake. When you throw a stone or something heavy in the water, so the water is gonna shake. So there is going to be a diffuse reflection when that happens. So to get a better understanding, you can see the pictures side by side, and you can clearly observe the major difference between specular reflection and diffuse reflection. So basically the reflection is being changed only and only because of the change in the medium where the light ray falls. Alright, like if it is smooth and standard surface, then specular reflection will be formed, and it's not regular and it's regular, not kind of good. It will form a diffuse reflection. That's it. So that was about types of reflection. Now let's move a little bit ahead and let's look at laws of reflection. So by remembering the word laws, I remember studying social. So I have been taught that we have a constitution. So as we live in India, we have Constitution of India, and there are tons of rules that are being written in the Constitution of India, and we should follow all of them. And if we don't follow, we'll be arrested or will be taken to the court, and the court tells what to do, as we broke the law that is being mentioned in the Constitution of India. Constitution of India contains all the laws that we have for humans, but even reflection has some laws. Oh, what can be the name of that? So I will name it myself. So I'll call it Constitution of Light. I will call it Constitution of Light, and the logo will also be something like this. Okay, so what are the laws that are being given in the laws of reflection? So will there be ton of rules for the laws of reflection too? Will light also have some many, infinitely many that no one knows laws for their family too? Oh, let us find out. So before that, I have a doubt. So as we humans have the judiciary or court for punishing the people who don't agree and abide by the rules of the Constitution, right? So is there a code for a light and reflection too? That when that particular ray or particle does not actually abide by the rules present in the Constitution, then would they get punished too? Oh, I'm curious. Let me know in the comment section. Does light have a court or no? Alright. So basically there are only two laws for reflection. Law 1. Very simple. Angle of incidence is always equal to the angle of reflection. So I've explained in detail just now about the incident ray and the reflected ray, and how the angle of incidence and how the angle of reflection is being formed. And you can look into this picture that is being given so that you can get a clear understanding. So remember this law, that angle of incidence is equal to the angle of reflection. It's as simple as it. So we can also take the angle of incidence as theta 1 and the angle of reflection as theta 2. So theta 2 would be equal to theta 1. It's in the form of mathematical way. Cool. So let us move on to the next law, the law 2. The incident ray, the reflected ray, and the normal to the surface of the mirror all lie in the same plane. So all the things that we have learned, remember everything, write everything, whatever you know, and just write all lie in the same plane. That's it. Law 2 done. Simple, right? And I'm kind of jealous of light now. They just have two laws. They can just chill around in their nation. But how about us? We have tons of laws in our constitution. Aha. Okay, never mind. Let's move ahead. So let us look at characteristics of image formed by plane mirror. So how does it act in different situations? As we act on in front of our teachers before the PTM day is completely opposite to the last day of our school. So does the plane mirror also do the same, or does it stay in standard way? Let's get to know. So all the characteristics of plane mirror are standard. They cannot be changed anywhere or anytime. And the laws are also standard. They cannot be changed, just like our laws. So let us read each of the characteristics of image formed by plane mirror. So first characteristic is that the image formed by the plane mirror is actually virtual and erect. So you might be knowing that images are of two types, which are real and virtual. If you don't remember them, I will leave a link in the description so that you can go there and check out more and remember. And then the second characteristic is that the image is formed behind the mirror. The third characteristic is that the size of the image is always equal to the size of the object. Means if you go and stand in front of mirror, the image that is being formed in the mirror is always has the same height as of you, unless it's a magical mirror. Okay, so laterally inverted image. So where the image is formed by the mirror is laterally inverted, means image of the left side visible on the right side, and then the distance of the image behind the mirror is same as the distance of an object from the mirror. So these are all the characteristics that I have learned in the previous classes, just a revision of them now. We also have some applications of lateral inversion. You might be just thinking lateral inversion is so dumb, it just makes things more complex. But no, it has some applications and useful things to do with. So the word ambulance is written in reverse direction so that it can be read correctly in rear view mirror of vehicles going in front of it. You might have also be seen in some traffic areas if you just go out. You might not observe it if you just play Minecraft all day in your home. Just kidding. So before your mind blows up, I've eaten so much part of your brain now. If I don't leave some part for you to think about anything else, I will stop it here for today. So this chapter will be continued in the next part. Make sure to subscribe to the channel and hit the bell button beside it to make sure that you'll get the notifications of all my latest videos. Thanks a lot for watching this video. Have a great day.